Hello everyone, I'm going to tell you how to use the MFA Decisions module here. So for this we need this blue board called the Decisions module, we need the 6-volt battery here, we need the battery connector here, and we'll need several of these little black leads here. So the Decisions module is made up of the left hand side here, which has some inputs. So we've got a slide switch which you can move up and down. It's got a light sensor here, so this is also called an LDR or light dependent resistor. You can just put your finger over it to block the light. We've got a temperature sensor here. You can warm this up just with the heat from your finger, and that will cause this input to come on. And we've also got a push switch here, so just press that on to make this one come on. At the right hand side we've got 3 outputs. We've got a buzzer which makes a high pitched buzzing noise. We've got a relay which is an electrical switch. Now when this gets triggered you'll just hear a slight click and you'll just see something move inside this casing. And then we've got a small lamp here which obviously you'll see when that comes on. In the middle we've got 3 things called logic gates. And these each have inputs and outputs. So the inputs are at the left, the outputs are on the right, and the names of the logic gates really tell you what they do. So the NOT gate will produce an output when there is not an input. The AND gate will produce an output when there's an input here and an input here. So there has to be both of these inputs before an output will come out here. And the OR gate will produce an output here when there is an input here or an input here. And these points, the inputs, outputs, are all labelled with letters so that we can be quite clear and specific what we're referring to. So let me give you some examples of how you could use this and how we could set up some interesting circuits and things with it. First thing is to connect up the battery. So to do this we just have to put this lid on the battery and twist it so it's nice and firm, and then there's a connecting lead which just goes into this position here, and you'll see straight away that there's an LED come on in 2 places. First of all the NOT gate, and that makes sense if you think about it. There's an output but there is not an input, so that's doing its job perfectly well. The light sensor has the LED coming on. That's because I've got quite a bright light shining on it. If I cover that up with my finger though, you'll see that goes off. Okay, so what can we do? Well, the first one I'm going to just show you. I'm going to set up a circuit where we're going to make a bulb come on, this bulb, when it is not light, in other words when it's dark. So this would be like an automatic light, a security light perhaps, that comes on when it gets dark. So what we're going to do here is connect the light sensor to the NOT gate. You'll notice now that this has gone off because we have got an input. I'm going to connect the output from the NOT gate to the lamp. Okay, so this lamp will come on when it is not light. It's light at the moment so the lamp is not on, but if I make it dark according to the light sensor, there we go, the lamp comes on. So simple example of a sensor triggering an output using this logic gate. Okay, what else can we do? Let's just disconnect these. So the next one I'm going to do is a circuit where we'll make a buzzer come on when we have a switch on and when it's warm. So you can tell from the words I'm using that we're going to use the AND gate. So I said we were going to make a buzzer come on. when a switch, that's this one, is on and when it's warm. So we're talking about the temperature sensor as well. So I'm going to switch the switch on, so the LED comes on, but we're not getting an output yet because it's not warm enough. This would be the kind of circuit that you might get in something like an iron perhaps, where when you turn the heater on, you also need to have a temperature sensor to make some kind of output happen when the iron gets warm enough. So I'm now going to just put my finger on the temperature sensor, it will warm up, this LED will come on, and at the same time the buzzer should start sounding. You'll also see that LED coming on to say that there is an output from the AND gate. There we go, it didn't take much doing. It should cool down when I've taken my finger off as well. There we go, it's cooled down again. I'm actually in quite a cool room here. If you do this in a warm room, then actually that temperature sensor will probably be, it will be triggering an output all the time. Okay, what else can we do? Let me just take the wires out first. So I've shown the NOT gate, I've shown the AND gate, so I'm going to do one with the OR gate now. So I'm going to do one here where, let's imagine the situation is that we want to trigger a sprinkler system to come on. Now that would be linked to well, a fire happening in a room. So imagine you're in one of your labs, and there's a fire breaks out in the corner. You really need two ways of triggering the sprinkler system. You want an automatic way of doing it in case there's nobody there to trigger it manually, but you also want a manual system in case the automatic system isn't working or isn't working quickly enough. So I'm going to connect our temperature sensor and the push switch through the OR gate. I'm going to send it to the relay. So the relay would connect to the sprinklers and turn them on. The temperature sensor would be the automatic system of picking up that there's some heat from the fire. The push switch would be your manual button on the wall that you would press if you see that a fire's broken out, but maybe it's a distance from the temperature sensors and you want to trigger the sprinklers really quickly. So, push switch into the OR gate and temperature sensor into the OR gate, and the output is going to the relay. Okay. So obviously nothing's happening at the moment. That's because we're not triggering any input here. If you just watch the relay here and listen when I press the push switch. So this would be you pressing the button on the wall. Okay, and you can see that we've got an output because the LED has come on there by the OR gate, and you might have just seen and heard the relay being triggered. So it works with the push switch, or there we go, it's worked with the temperature sensor as well. Now of course, if this were a real sprinkler system, you'd want the sprinklers to stay on even when this had cooled down, or when you took your finger off the button, certainly, because you might have to press the button and then run out of the room to get out of the way of the fire. So clearly this is a fairly simple example of how a system like that might work. Now that's the basic operation of the decisions module, but you can do some things that are a little bit more complicated. You can, for example, take an output here, and instead of taking it straight to one of the output devices here, you could actually send it to another logic gate. So you could run more than one logic gate together. And there is an example I could give you of that. Let's suppose you wanted a security light to come on, but you didn't want the light to be on all the time when it was dark. You only wanted it to come on if it was dark and something else was happening, like for example a pressure pad was triggered, so maybe somebody standing in front of the front door. Now this push switch can act as a pressure pad, so we want the output. We'll say we'll have a lamp here because we said it was a security light. We want the output of the lamp to be triggered when it is dark and when somebody stands on the pressure pad. So the first thing really is to think we've got darkness, so we're going to have to use our light sensor, but that's going to have to go to the NOT gate because we want an output to be triggered when it is not light. We want the lamp to come on when it's not dark and when the pressure pad is triggered. So you'll notice I've taken it from the NOT gate to one of the inputs to the AND gate. The other input to the AND gate is going to come from the push switch, and we'll take the output from the AND gate then to the lamp. So it's dark, okay? The lamp hasn't come on yet because we don't want it to be on all the time when it's dark. We only want it to be on when it's both dark and when somebody stands on the pressure pad. So there we go. So that's an example of two inputs and two logic gates being used to set up a fairly useful circuit. So I hope that's been useful, and see if you can have a go at using these. And I think that pupils might find this quite useful and could investigate some things of their own.